So now let us look at these 4 very basic questions to understand the concept that we have learned. So let us say that we need to solve log x to the base 2 greater than 0. So how do we solve this? So let me do it in 2 different ways. One is the long way, that is complete way. The other is a shortcut. So log x to the base 2 is greater than 0 can be written as log 1 to the base 2, right? Because we know that log 1 to any base is equal to 0. So now log something to the base 2, log to the base 2 is a function for me. Log to the base 2 is a function. The arguments are x and 1. Log x to the base 2 is greater than log 1 to the base 2. Now if you remove this function, what is the sign that arguments follow? That depends on whether you are removing an increasing function or a decreasing function. Log to the base 2, because this base is greater than 1, it is an increasing function. So I am removing an increasing function. So x is greater than 1 is the answer. X is greater than 1. Now if you go to the next question, log x plus 5 to the base 4 is less than 1. So log x plus 5 to the base 4 is less than 1 can be written as log 4 to the base 4. So now if you want to go to x, let us remove this function. Log to the base 4, what is the nature of this function? It's an increasing function. So I can remove this. So the arguments follow the same sign because I am removing an increasing function. This implies x is less than minus 1. X is less than minus 1. So whatever I am doing, these are the values of x for inequality to be valid. So if you want the complete answer, you also have to make sure that the log function is defined. That comes under the topic of functions. So what are the values of x for which log is defined? For log to be defined, x has to be greater than 0. And for this inequality to be valid, x has to be greater than 1. So the effective solution is x is greater than 1. Similarly here, log x plus 5 to the base 4 is less than 1. For this inequality to be valid, x should be less than minus 1. But for this logarithm to be defined, x plus 5 has to be greater than 0. X has to be greater than minus 5. So both these inequalities have to be satisfied. That's the effective answer. That is, x lies between minus 5 and minus 1 is the effective answer for this inequality. Now if you go to the third one, log x plus 3 to the base 0.2 is greater than or equal to 2 times log 0.2 to the base 0.2. Log 0.2 to the base 0.2 is nothing but 1. Now according to the properties of logarithm, this 2 goes onto the power, right? So it's greater than or equal to log 0.04 to the base 0.2. Now, as you have to go to the arguments, you need to remove this function log to the base 0.2. And we have seen that if the base is in between 0 and 1, this is a decreasing function. So this function is a decreasing function. If you remove this function, so x plus 3 will be less than or equal to 0.04. The sign of inequality reverses. This implies x is less than or equal to minus 2.96. So this is the solution for this inequation. Further, you have to take x plus 3 greater than 0 also. So if x plus 3 greater than 0, x is greater than minus 3 is also should be valid. So x is greater than minus 3 and less than minus 2.96. It has to lie somewhere in between these two. That's the answer to this inequality. So before going to the fourth question, so let us try to solve this. Let us try to get these solutions using the shortcut method. So each time you don't need to do complete solution. So if you want to get the right answers, what you can do is, so log x to the base 2 is greater than 0. So log to the base 2 is an increasing function. So when you convert this into exponential form, the inequation does not change. So x is greater than 2 power 0. That means x is greater than 1 is the answer. So that's the direct answer for this inequation. So x is greater than 2 power 0. Because this base is greater than 1, the sign of inequality does not change. And here, the base is 4, hence the base is 4, hence is an increasing function. If you convert this into exponential form, the inequation does not change. So x plus 5 is less than 4 power 1 is 4. This implies x is less than minus 1. So this is the solution for the inequation. For the definition of this function, you have to separately test the condition. So x plus 5 has to be greater than 0 also. This implies x has to be greater than minus 5. So these two have to be satisfied. So if you go for the third function, so here the base 0.2 is less than 1, that is in between 0 and 1. So x plus 3, when you convert this into exponential form, the sign reverses. So less than or equal to 0.2 whole square. It is less than or equal to 0.04. So x is less than or equal to minus 2.96. So this is for this inequality to be valid. But for this log to be defined, x plus 3 has to be greater than 0. X has to be greater than minus 3. So x has to be greater than minus 3 and less than minus 2.96. So x has to lie in between these two values. So now let us go to the fourth question. So now if you look at this question is slightly different because the variable is not in the argument, the variable is in the base. So log 0.5 to the base x is greater than 2. So I'll solve this in two different cases. Case 1, if x is greater than 1. If x is greater than 1, I can directly convert this into exponential form, that is x square is less than 1 by 2. X square is less than 0.5 is 1 by 2. So x square less than 1 by 2 implies x is in between minus 1 by root 2 to plus 1 by root 2. So if x is greater than 1, then x has to satisfy this interval. And so let us assume x is less than 1. That's the second. If x is less than 1, if I convert this into exponential form, the sign of inequality reverses. That is, x square is greater than 1 by 2. This implies x is either greater than 1 by root 2 or x is less than minus 1 by root 2. So these are the two cases. So in the first case, there is no solution, as you can see, because I have solved the first inequation in the case when x is greater than 1. But I got the roots as minus 1 by root 2 to plus 1 by root 2. So my x has to lie between this. There is no common interval. That means there is no solution here. And if x is less than 1, I am solving it in x less than 1. So the condition that I got is x is greater than 1 by root 2 and x is less than minus 1 by root 2. Less than minus 1 by root 2. So the effective solution can be x belongs to 1 by root 2 comma 1, right? 1 by root 2 to 1 union minus infinity to minus 1 by root 2. But this is not valid because for this logarithm to be defined, the base has to be positive. So this solution is not valid. So only this solution is valid. And 1 has to be open because this x base cannot be equal to 1 from the definition of logarithms. So the final solution for this inequation is x is in between 1 by root 2 to 1. So to check whether this is a closed interval or open interval, so you have an open interval here also because there is no equality. So open 1 by root 2 to 1 is the answer. So now if you take a look at exponential inequalities, so we solve it something like this. So if 2 power x is greater than 4, so I write it as 2 power x is greater than 4 can be written as 2 square. Now 2 power, here also you have 2 power. So 2 power something is an increasing function. because an exponential function is increasing if the base is greater than 1. So 2 power x is greater than 2 square. 2 power is an increasing function. So if you remove this, the sign of the arguments does not change because we are removing a increasing function. So if you go to this, so 1 by 2 power x is less than, I can write 1 as 1 by 2 power 0. So if you remove this 1 by 2 power, 1 by 2 power something is a decreasing function. Hence, the sign of the arguments reverses. Or you can also do it like this. This is 1 by 2 can be written as 2 power minus 1. So 2 power minus x is less than 1. So 2 power minus x is less than 2 power 0. Now if you are removing 2 power, if you are removing 2 power something, so 2 power is an increasing function. So the arguments follow the same relation. Now this is minus x less than 0. This becomes a linear inequality. If I uniformly multiply both sides with minus, now the sign of inequality reverses. So finally you got the same answer. Now if you have this is the combined inequality, exponential and modulus. So first let me solve the exponential part. So e power mod x is less than or equal to e power 0. And e power is an increasing function. So the arguments have to follow the same inequality. Mod x is less than or equal to 0. Mod x can never be less than 0. So mod x has to be equal to 0. That means x is equal to 0. That's the solution. Now if you go for the fourth one, 10 power log x to the base e is greater than 100. So 10 power log x to the base e is greater than or equal to 10 square. So 10 power is an increasing function. So the arguments also follow the same inequality. Now log x to the base e is greater than or equal to 2. Again, e log to the base e is an increasing function. So if you convert this into exponential form, x is greater than or equal to e square is the answer to this question. Thank you.